Hi, this is Ashok Kumar, working as Associate Professor in Department of Triple Ramchandra Public Engineering, ALU. Now, I would like to give introduction to instrumentation in this presentation. We'll see the contents of this presentation. We'll go for first introduction. Next, we'll move for definitions like measurement, measuring. And next one, we'll see functional elements of instrument. Coming to introduction, so the measurement of any quantity is having very important role. In instrumentation subject, the first thing we should know is what is meant by measurement. So the measurement means to monitor a process or an operation. That is nothing but measurement in general. Such a measurement gives in-depth knowledge of the process and the parameter and helps in further modifications if required. Thus, the measurement provides us with a means of expressing a natural phenomena or the natural process in quantitative terms. Basically, if you see the definition, clear definition of measurement of a given parameter or a quantity is the act or result of a quantitative comparison between a predefined standard and an unknown quantity to be measured. So if we go for clear explanation of this definition, measurement of a given parameter or quantity is the result of a quantitative comparison. What is meant by quantitative comparison? So the comparison should be taken between two quantities. First quantity is predefined standard value. Predefined standard value means if you have any instrument, to get it is having a standard value should be predefined. That is the true value, which is nothing but true value. An unknown quantity to be measured. Unknown quantity is nothing but through that instrument, what is the quantity you are going to measure, that is called unknown quantity. So the comparison should be taken between true value, that is nothing but predefined standard value, and unknown quantity that we are getting from that instrument. Here we will take comparison between these two parameters. This is called measurement. Coming to measurement. Measurement is nothing but the physical, chemical or electrical quantity to be measured is called measurement. Simply the quantity which is going to be measured is called measurand. The technical name we can call it as measurand. Now we see problems in measurement. All of you know, since we are doing labs, so many experiments we are doing in different labs, the first problem we face with error. The first problem we are facing with error. The major problem with any measuring instrument is the error. So in labs, we can have so many precautions are there. Readings are taken without parallax error. That is the first one we have. So hence it is necessary to select the appropriate measuring instrument and a measuring procedure which minimizes the error. Whatever the procedure we are choosing, whatever the instrument we are taking, that should be in a position that the error should be minimized. The measuring instrument should not affect the quantity to be measured. Now we move for functional elements of an instrument. Here the block diagram shows functional elements of a basic instrumentation system. Here we have so many blocks are present. Each and every block is having its own significance, from primary sensing element to data presentation element. So first block is primary sensing element, second one is variable conversion element, third one is variable manipulation element, fourth one is data transmission element, fifth one data storage element, and last one data presentation element. We'll see one by one each and every block. Coming to primary sensing element first. Here for primary sensing element, the input will be given is quantity to be measured. Whatever the quantity we are going to measure, that we are giving as input to primary sensing element. Okay, so what is the significance of primary sensing element? The measurand, what is the measurand? The quantity to be measured is called measurand. The measurand is first detected by primary sensing element. The primary sensing element transfers the measurand to variable conversion element, which is the next block of primary sensing element for further processing. So the output of primary sensing element will be given to variable conversion element. Initially, if we give any parameter to be measured, so in any instrument, you can have so many parts are there. Out of all parts, the part which senses the quantity which we are giving as input, that part is called primary sensing element. The output signal of the primary sensing element is a physical variable such as displacement or voltage or anything. That is nothing but primary sensing element. Coming to variable conversion element. Already told to you the output of primary sensing element is giving as input to variable conversion element here. What is the significance of variable conversion element? The output of the primary sensing element is in electrical form such as voltage, frequency or any other electrical parameter. Such an output may not be suitable for actual measurement. Actually, we need to have one set of measurement is there, but the output we are getting from primary sensing element is not in a position to take the measurement. So here this variable conversion element do the process in our desired format. See, for example, if the measuring system is digital, then the analog signal obtained from the primary sensing element is not suitable for the digital system. Actually, my output should be taken in digital form. But here the output of primary sensing element, for example, is given in analog form. So analog form cannot be shown as a display in digital form. So I need to have one analog to digital converter which converts analog input into digital output. So here analog to digital converter is required, which is nothing but variable conversion element. So variable conversion element converts the output coming from primary sensing element to our desired format, which can be measurable. Now coming to variable manipulation element. In variable manipulation element, the output of variable conversion element is giving as input to variable manipulation element. Here variable conversion element, variable manipulation element, these two together called as data conditioning elements. We'll see what is meant by data conditioning elements. See here, variable manipulation element is only very tricky part, very important part and difficult part. The level of the output coming from variable conversion element may not be enough to drive the next stage. Next stage in the sense coming stage. So that means variable manipulation element can amplify, that means increases or attenuates, that is decreases the output getting from the variable conversion element without changing the original nature of the signal. For example, if you see in case of a meter, if the amount of current to be measured is so small, it may not be enough to cause any deflection in the magnet. So here transformer can be used to increase the voltage to get enough deflection. That means here by using transformer, I am increasing the voltage level without changing the original characteristics so that I can drive the next circuit. So in this case, transformer will be taken as data manipulation element. Okay. Now, see one more example here. Already I explained here about the transformer. Okay. In case of ammeter, just now I explained no. So transformer can be used to increase the voltage to get enough deflection. So transformer will be considered as data manipulation element. Sometimes the output may be get affected due to unwanted signals. Some disturbance may occur. Such signals should not be enter into our output. So we need to eliminate those unwanted signals, and I should convert my output in a pure and acceptable form. Such process is called signal conditioning. Signal conditioning is nothing but removing unwanted signals in the output of variable manipulation element. So that's why, since signal conditioning is happening in variable manipulation element, variable conversion element and a variable manipulation element, these two together we can call it as data conditioning elements. Now coming to data transmission element. This is the next block of variable manipulation element. So simply data transmission, the name itself implies when the elements of the system are physically separated, it is necessary to transmit the data from one stage to another. Whatever the output we are getting here, this should be transferred to next level. Whatever the display here, the next thing is data display. So to carry the output of variable manipulation element to data display unit, the mediator is data transmission element. Coming to last one, data presentation element. Whatever just now I told you, data display element or data presentation element. The transmitted data may be used by the system finally for monitoring. Here we can have a display. This display, or it may be the output, we can take as recordings or printed data, whatever the application we are using. Depends on that application, we can get the output. The output finally will seen by observer. Now coming to example for basic instrumentation system with all functional elements, that is nothing but here ammeter I am taking. See current, what is the position here? Current. I am going to, what is the purpose of ammeter? Purpose of ammeter is used to measure the current. So the current I am giving as input to primary sensing element. In ammeter, primary sensing element is nothing but moving coil. Moving coil which senses the current first. That's why we can call moving coil is primary sensing element. From primary sensing element, the output is going to next level, that is nothing but variable conversion, variable manipulation. Together, I already told to you, we can call it as data conditioning element. Here, magnets and other components will form as data conditioning element, which delivers force, physical force. This force will be going to data transmission element. Here, data transmission element is nothing but mechanical linkages. So, because of this force, the pointer which lies in the submitter will move and shows the scale. Finally, we can see the output in data presentation element. The data presentation element parameters are nothing but pointer and scale. So if I apply some current, whatever the current I am applying, that magnitude finally I can see in scale, point with pointer and scale on display. Finally, that will be observed by observer. Now, what are the outcomes of this topic, of this presentation? Students can able to learn basic concepts of instrumentation system, functional elements of the instrumentation system. In functional elements, we have seen different blocks of functional elements with an example of ammeter. Okay, thank you.